Hello, welcome to lecture 9. Today I am going to talk about constructions. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and details are given below. So in construction, we start with bisecting a line, which we have done earlier. This is again recapitulating it. How do you bisect? I take from point A and make an arc here, and then same distance, whatever the distance from here to here, same distance from point B, you make another arc here, and this point is C. Similarly, here also you do from point B and then from point A and D, and you join these 2 points. So this will bisect. So this is bisecting the line segment. This is by using compass. Now bisecting an angle, this is an angle here, angle O or Q it is, PQR. So you draw an arc here, and from this point you again draw an arc. This is from A, you draw this arc, and from B you draw this arc. So you get this point here, and you join this point and this point. So this will bisect the angle. How do you drop a perpendicular from a point? Say you have a line and you want to drop a perpendicular line. So what you do, you from the compass tip you keep it here, and the pencil you draw this arc, and then this point A and this point here, okay, not A, this point here, and this from here you draw again an arc. So you get this point and this point, you draw it. So this will be perpendicular. Okay. Now we'll draw a square. Suppose you have given a side, say A, B here. So you have to draw a perpendicular line. So very similar to this, you draw an arc from this point B, you draw and call it E and F. And from E and F, you draw one arc. So this will be like, it will be bisecting this point from EF is similar to this. So EF will be bisected, and if you from this point B, if you extend it, then you get a perpendicular. Now you know this AB. So you take this compass, mark here as C, then you mark D here, and then from A you mark with the same radius AB with the compass. So you can make a square. How do you draw a equilateral triangle for a given length? This say length is say 6. Equilateral means some 6 unit, okay, centimeter or inch. Or so what you do is, I take from here and I take this point and draw an arc here, and from here I take from this point and I draw another arc. Okay, I keep the pin here, the pencil here, same distance. Suppose this is AB, same distance, and you draw an arc here. So if you do, this distance will be equal to this distance, this. So side, they are all same. So angle will also be same. Okay, that we have seen earlier. Or if you want to draw not an equilateral but some other, say you have drawn BC is 6 centimeter, then if you want this length as 4 centimeter, you draw an arc, and if you want this length as 5 centimeter, you measure 5 centimeter from the scale and draw an arc. Okay, so you can draw a triangle. This is for equilateral, this is for any triangle. So how do you inscribe a polygon? It's very easy for a triangle, it is very easy that you take this is your circle, and from A to B is the diameter. So from this you measure the radius, okay, with the compass and draw an arc here. So it will intersect here and here. So from this intersection point C and D, you draw a chord and then join to this point A, and from C to point A you get a equilateral triangle here also. Now how to inscribe a square? You draw a circle, draw a diameter here, AB is the diameter. Now you want to draw a perpendicular line in the center, but we do not know what the center is. You take the compass, from A you draw an arc, and from B you draw another arc with the same distance. This from this dash line to B should be same, and here also this dash line also from A, the distance should be same. So you get an intersect here. Now you can join this. So this will pass through the center and it will be perpendicular. So now once you have this point and this point, then you joined these 4 points. So this becomes a square. But things become difficult when you go to say pentagon or higher angle. So I will tell you the more easier way to do it, and this is a general method. What you do is, this is for the given side length. Suppose this side length is given, I have shown you how to draw a square. So draw a square first, and then from the square you bisect this square here. This is a cross here, you can see. Similarly below also cross will be there. You bisect this line AB along this. You draw one diagonal and then draw one arc here. So this intersection, the perpendicular bisector this line and this diagonal, this is 4, and this curve and this perpendicular line is 6. Now I have to bisect this 4 and 6. I am again bisecting it here, so I get 5. So this is a trick. Okay, you can think the logic, but it is beyond the scope of the present class. So this only a trick I am going to show you. So you draw, take this length 4, 5, 5, 6 is the same equal because it's a bisector here. I have bisected it. Then 6, 7, 7, 8. Okay. And then you know from point 4 you take this diagonal and draw a circle. The radius will be from this 4 to this A to point 4. For a pentagon, you take this 5, take this radius and draw a circle. Okay, you will get this circle. Okay, now you know this length. Then you just take this length and mark this circle. Just mark it here. So you will get a pentagon. Similarly, if you want to get hexagon, this is go to line this point 6, take a compass, okay, from 6 to A and draw a circle, this big circle, okay. And then once you make this circle, this is a trick actually. So once you make this circle, they take this, you know, this is given, length of your choice. Then you measure this and then mark it here, 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 here with same length, okay, with the compass. So you will get here hexagon. So this is another way of drawing a polygon inside a circle, okay, provided you are given what is the side length which is of your choice or is given to you. But now suppose you have given a circle and you have been asked to inscribe a polygon. Earlier in this case you have been given a side and then from there they have asked you to draw polygon with one particular side. But here you have been given a circle with particular diameter and you have been asked to make a polygon inside the circle. So what you do now is you divide this diameter AB. Suppose you want to make a pentagon. So you divide the diameter into 5. 1, 2, 3, 4, 5. You divide. This is your hexagon. 1, 2, 3, 4, 5, 6. Okay. 6 equal. And then what you do is, it is very easy to divide a line. You know that you draw a line here and with a compass, with any measure, this A to 1 can be anything, any measure. You draw equal here. Okay. Equal. It can be near also, here, 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 anywhere, but all this distance A to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, this should be equal. You join this point to the B and draw parallel line. Once you draw parallel line, this, if you draw small, only the slope will be different, but they will divide, if they are parallel, they will divide into that many numbers, whatever number you have divided. Here it is 5, so it will divide this diameter into 5. Here also, so this is for the hexagon. So the trick is, here the trick is, suppose if you want to draw hexagon, you divide into 6 and then you take the diameter of this circle and from here you draw one more big circle and from D also you make a big circle and you will get an intersection point here, and from this intersection point you draw one line either through 2, from 2, so it will intersect at B, or through 4. You have to leave 2 either from left hand side 2 or from right hand side 2. Why you have to leave 2 is beyond the scope, but this you think it is a trick and this can be used for inscribing any polygon with any number of sides. If you want to draw pentagon, again you have to leave 2 or from left or right. So once you leave 2, see this is left from the right. Then this angle, where it intercepts from this to this becomes, you draw a chord, this becomes the side. So this measure you know, then you take again BC will be CD. So you know the side, you mark it and you will get a hexagon. Provided you divide the diameter into 6 equal parts. Hexagon means 6 sides. So 6 equal parts, leave 2 either from here and here. You draw a dash line and then you will get, you will divide the circle, you will get the, this is 1/6, okay, then 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 1, full circle. Okay, similarly, if you want to draw, say this is how many sides are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, decagon. 10 side means decagon. So in a decagon, so you divide this diameter into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So in 10 equal parts you have divided. Now what you do, again you take this diameter, draw an arc from point P, and from point A you draw an arc. And then again from Q, leave 2, 1, 2 you leave, and draw a line here. So this will be 1/10. Okay, 10 side, this will be the one, because 10 divide you have done it. So this will be 1/10 of the circle, of the circumference. So once you know this A, B, then again with the compass you mark C, D, E, F like this, and you will get 10 side. And then join from A to B chord, and you will get a decagon. So there is another way. Suppose this is how many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you take from point, the center point, and you draw a semicircle, okay, and break this semicircle into 9 equal parts. And you can do, you leave this number 1, and from 2 you join 2, then you 3, then 4, like this, 7, 8, and this is the 9th one. So this way also you can construct it. Okay. Okay, now we will take some example from your book, from chapter 11. Some construction examples. The construction 11.4, this is from your book. It says to construct a triangle given its base, a base angle, and sum of two sides. That is, given its base, the base angle, and the sum of other two sides. That is, suppose I call it triangle ABC. So it is given AB plus AC together. Okay, AB plus AC. So this AB plus AC I can call it as BD. Okay. So here I have to find a point A on BD. D is a point which is marked, which is AB plus AC. So I have to point A in this ray X. So how do I find this point A? So what I do is I connect C to D. Okay, I connect this C to D, and I get an angle D here. And now I draw a ray having the same angle, this angle here. I can move this ray till I get the same angle, and I call this intersection point, I call it A. Now since this angle and this angle is same, okay, so this is like isosceles angle. So now one can say this AD equal to AC. So connect C to D to get angle D, then draw ray Y from C and intersecting at A, and move ray Y, you move ray Y such that angle ACD is equal to angle D. So this implies that this is an isosceles, so this means AD is equal to AC. So BD is equal to this, BD is equal to AB plus AC, because AD is AC. Okay, the next construction 11.5, it says to construct a triangle given its base, this is BC, a base angle, this angle has been given, and the difference of the other two sides. So we have to construct a triangle where this BD equal to AB minus AC. This is, we have to prove it. Okay. So here draw X with angle B. This draw ray X with angle B. Connect D to C. That is, connect this one is given to you in this. So connect D to C. Then draw perpendicular bisector of this D to C. Okay, extend this line to cut the ray. Okay, and call this point A. And then triangle ADC is an isosceles triangle. So since it is an isosceles triangle, AD equal to AC. So BD is therefore AB minus AD. So I have written, but BD is equal to AB minus AD. But AD is equal to AC. So BD is equal to AB minus AC. So this BD is the difference between this length and this length. Okay, now we will discuss construction 11.6. It says to construct a triangle given its perimeter and its two base angle. That base angle, suppose is a triangle ABC, then angle B and angle C has been given, and sum of all the sides, that is the perimeter, that is BC plus CA plus AB is also given to you, and you have asked to construct a triangle ABC. So what is the trick? I draw a straight line here, XY, and this is a sum of all the sides of the triangle, say, because what I will do is I will cut it, I will divide into 1, 2, 3 part, and then I will of course wrap it here to make a triangle. So this length is given to me, and since this length is given to me and some angle is given to me, angle B and C, so I can draw this one. And if I can cut and draw parallel here, and if I can cut here and draw a parallel and put the line parallel to here, then I will get a triangle ABC. So how do you go about doing it? You from point X you draw one ray, and from Y also you draw one ray equal to this is my B here somewhere, and here somewhere it will be C. So this angle will be equal to, I take it as equal to B, and this angle I take it equal to C. This B can be equal to C or can be different also. So here I have say this, draw XY equal to XB plus BC plus CY. That is in the three parts, which I will later on call as AB plus BC plus CA. So let angle X equal to B, which what I said, on ray L, on this ray L, and let angle Y is equal to angle C on ray M. Okay, this is a ray M. So we have to prove that XB is equal to AB and CY is equal to AC. So now first we have to find some point, say A here. How do we find the point? I bisect angle X and angle Y. This is angle X and angle Y I bisect, and extend this bisector till it intersect at some point and call it A. Then from this point A to X and A to Y, you draw a perpendicular bisector. So I call it PQ here, perpendicular bisector. But once you make this perpendicular bisector, then I know you join this will intersect at this point here, and I call it a B, and you joined AB. Okay, and since this is a perpendicular bisector, this side is equal to this side, and this angle is equal to, so it will be this angle. So it is an isosceles triangle. So since it is isosceles triangle, AB will be XB. So similarly here, if you draw perpendicular bisector here, okay, and you draw from, this will intersect here, and you call it point C. So connect this AC here, and now since this is a perpendicular, this side and this is a bisecting, this AY is bisected. So this again becomes a isosceles triangle, and so AC is equal to CY. Okay. So that's what I have written here, that find point A by bisecting angle X and angle Y and extrapolating the bisectors to get A. Then draw perpendicular bisectors to XA and AY as PQ and RS is different. Then triangle XAB and YAB are now two different isosceles triangles. But if suppose this angle X and angle Y are different, okay, if they are same, they will be similar, but since they are different, we consider general. So this implies that since these are isosceles triangles, so this means this is isosceles one triangle, this is another isosceles triangle. So since this is isosceles, this XB will be equal to AB and CY will, so this is proved. External angle of XAB, this is, suppose I take an external angle of XAB and triangle YAB. Okay, now how do you know this angle is angle X, what we have taken, angle B, and this one is angle Y, because I have taken angle X as angle B and angle Y as angle C. So the external angle of triangle XAB is this one. So this angle is sum of this plus this, sum of two opposite internal angle. Okay, so this angle is half, and this is half of this angle. So this half and this half of angle X. So this become, so angle B is equal to angle X. Similarly from here, the external angle, this is angle C, okay, of this triangle, angle C, it is sum of opposite two internal angle. So this will be this is the sum of two, means this angle plus this angle is Y, because this angle is equal to this angle, equal to this angle. So this will be equal to angle C. So angle Y will be angle C. Now we will take one example which is given in your book. Okay, this is similar to the construction which we did, just the last construction. It says to construct a triangle ABC in which angle B is equal to 60 degree, angle C is 45 degree, and AB plus BC plus C, this is the perimeter of a triangle, is 11 centimeter. So now values have been given. So values means this is angle B is 60. So we know that we have shown that angle B equal to angle X here. Earlier we have shown that angle C is equal to angle Y. So I have to draw this angle as 60 degrees. So it is very easy to get 60 degree. You draw an arc here, intersect with this line, you take same radius and draw another arc, and you join it, you will get an equilateral triangle, and this angle is 60 degree. So similarly 45 degree, if you can draw 90 degree, so you can draw 90 degree again. So you bisect this 90 degree, you can bisect it. Okay, I have shown how to bisect an angle, you will get 45 degree. So this line ray, I call it ray M. This 60 degree ray L, and this ray M from point Q is 45 degree. So similarly here what I had done, I had bisecting again this angle, this 45 degree and this 60 degree angle, okay, and made an isosceles triangle, okay, and this is 60 degree. So since this PB is equal to AB, which we have shown in earlier, and this AC is equal to CQ, by doing this construction I can make a triangle. So this angle B is 60, angle C is 45 degree, so angle A will be 75 degree, because the sum of internal angle of a triangle is 180. Now we have got all the angles. Is it possible to know all the sides? Yes, because you have been given this AB plus BC plus CA. This condition is also given to you. So this is beyond the scope of your book, but if students want to know how to find it, it's little bit of trigonometry. This is called the law of sine, says that for all angles of a triangle, okay, for all angles of a triangle, the ratio of the sine of that angle, the sine of the angle to its opposite side, that is sine of the angle, sine B by AC is equal to sine C by AB is equal to sine A by BC. This is what I have written. So this is a formula which can be derived, which you will derive in your higher classes. So just for your curiosity, so I know that AB plus BC plus CA. So I can write this BC in terms of AB as BC, I take it up. So BC is equal to sine A by sine C times AB. This AB will go up. This is the term. Then CA, this is your AC, or CA is same thing. CA in terms of AB is, suppose I got put CA, so sine B by sine C into AB, sine B by sine C into AB. So I take AB common outside, so I will get 1 plus sine A by sine C plus sine B by sine C, because AB I have taken out. So AB is equal to 11 centimeter divided by 1 plus sine A by sine C plus sine B by sine C. So these values, you know, from trigonometry you can know this is known value, this is also known, you can find the value, and so you can know what distance, what is the side, what is the length of side AB. So similarly you can find what is the length of side BC and CA. Anyway, this is for your general knowledge, but this is possible to know given all the three angles, and if you are given the sum of all the sides, then you can find individual side lengths. So we have finished the construction chapter, and I want to, and with this we have finished more or less the full geometry portion. And the geometry portion in your book is from chapter 5 to chapter 13 of class 9 NCERT mathematics books. So we have already summarized chapter 6, 7 and 10 in our earlier lecture. Chapter 5 contains only axioms and postulate. What is the difference between axiom and postulate? In geometry, actually axioms and postulate can be interchangeably used, but in math, postulates are generally axioms in geometry, but axioms are used in maths also, in other than geometry. There is nothing to prove axiom. This is all taken for granted. Postulate is also like they have postulated this, that is their idea, so which we have discussed in other chapters. So this we have more or less discussed that if the 2 points are there, only one line can pass through it, no more line can pass. So these are our postulates, you please go through it. There is nothing to prove in that chapter. We have so far covered chapter 5 to 13, but we have not summarized, for your completeness sake. Let us summarize chapter 8, 9, 11, 12 and 13, so that you will be convinced that yes, we have covered all the portion from chapter 5 to 13. This is optional, one can skip this, but brushing it up again along with me will be good, because maybe I may give some idea in bit while discussing the summary. Okay, we'll now summarize chapter 8 summary. In this chapter you have studied following points. Sum of the angles of a quadrilateral is 360 degrees. We have studied this. A diagonal of a parallelogram divides it into two congruent triangles. A diagonal, if you take it, it will make two equal triangle, which you have seen it. In a parallelogram, by definition, opposite sides are equal, opposite angles are equal. Diagonal bisects each other. If you take a diagonal, it will bisect, one diagonal will bisect the other and the other one bisect. So it bisects each other. The quadrilateral is a parallelogram if opposite sides are equal, or opposite angles are equal, or diagonal bisects each other. A pair of opposite sides is equal and parallel. Okay. So this is a quadrilateral is parallelogram itself, because if these conditions are true, here this quadrilateral will be called parallelogram. Diagonals of a rectangle bisect each other and are equal. Okay. And are equal, but they don't bisect at perpendicular angle. But if you take rhombus, they bisect each other but at right angles. Okay, they are perpendicular to each other. Similarly, if a square bisects, the diagonals of square bisect each other, they are also perpendicular and are equal. Okay. The line segment joining midpoint of any two sides of a triangle is parallel to the third side. That we have seen it. Go back and go through my lecture notes. A line through the midpoint of a side of a triangle parallel to another side bisect the third. So this is the same thing. Okay. Here you say if the line passes to the midpoint of two sides of a triangle, it's parallel to the other side. So it is, if the line itself is parallel and passes through the midpoint of one, so it has to go to the midpoint of the other side. Okay. Just go through my lecture notes. The quadrilateral formed by joining the midpoints of the side of a quadrilateral. This also we have seen it in order is a parallelogram. Now chapter 9. In chapter 9 you have studied the following points. Area of figure is a number. What is area? Is a number in some unit associated with the parts of the plane enclosed in that figure. Two congruent figures have equal area, but the converse is not true. You may have one triangle and one square having equal area, but they are not congruent to each other. If a planar region formed by figure T is made of two non-overlapping planar regions formed by figure P and Q, so if this T is formed by say some area P and area Q, then total area this T is equal to area P plus area Q. So two figures are said to be on the same base and between the same parallels if they have a common base and the vertex opposite to the common base of each figure lie on a line parallel to the base. Okay, that is some figure you have. The base are common, and another parallel line which is going. The vertex, both the vertices lie on that opposite parallel line. Then of course it has lot of properties which we have seen it. Parallelograms on the same base, this is what one of the properties, and between the same parallel have equal area. We have seen that if they have the same base and they are between two parallel lines, okay, the height is same, then because they will have same area, because it's a base into height. The distance between the two parallel line is a height. Area of a parallelogram is a product of its base and corresponding altitude. What I have said. Parallelograms on the same base or equal base and having equal area lie between the same parallelogram is the same thing. Okay, because height is same. If a parallelogram and a triangle are on the same base and between the same parallel, then the area of the triangle is half the area of the parallelogram. This also we have seen it. Okay, if both triangle and parallelogram are within the same parallel line, okay, base and the base of the triangle, base of the parallelogram lie on the same line, and the vertex and the opposite parallel line of the parallelogram lie on the same parallel line, then the area of the triangle will be half the area of the parallelogram. So triangle on the same base or equal base and between same parallel are equal in area. This is the same thing what I have said. This is true for parallelogram. This is also true for triangles. Area of a triangle is half the product of its base and corresponding. So area of a triangle is half times base into height. Okay, altitude is height. Triangles on the same base and having equal area lie between the same parallel is a similar thing which we have been saying. A median of a triangle divides it into two triangles. We have seen that the median is a line which you draw from apex to the centroid of the triangle. So it will bisect into two triangles of equal area. This is summary of chapter 11 which we have discussed today. Okay, what we have discussed today in the lecture: to bisect a given angle we have shown, to draw a perpendicular bisector of a given line segment, to construct an angle of 60 degree which we have shown, equilateral triangle, how to draw. Then to construct a triangle given its base angle and sum of other two. This we have seen as a construction. To construct a triangle given its base angle and the difference of the other two sides, that also we have done it today. To construct a triangle given its perimeter and its two base angle. That was the last one construction and one example which we did. So this chapter was mainly based on Heron's formula. So you have studied the following point. Area of a triangle with its side A, B, C is calculated by using Heron's formula, stated as area of a triangle is S into S minus A, where A, B, C are the sides which you know, and S also you can express in terms of sides. So once you know the sides, the length of each sides, then you can know the area. And area of a quadrilateral whose sides and one diagonal are given can be calculated. So even if it is a quadrilateral or any other polygon, you can break into many triangles and you know the sides, and you can, from the sides, you can know the area enclosed inside those triangles and you can sum it. Okay, now summary of chapter 13. In this chapter, you have studied the following points. Surface area of a cuboid. What is cuboid? Cuboid has 6 faces. It has the length, the breadth and the height. The breadth can be called as depth, length can be called as width. So this is the face. So there are 3 faces here. So this is 1 face, 2 face, 3 face, but altogether there are 6 faces. Each cuboid opposite sides will have the same face. Suppose front side and the back side, and then the left hand side and the right hand side. Similarly top and bottom. So here suppose, so this will come 2 times. So this is a cuboid. I have shown how to add all the parts. You can break into parts, each surfaces, and add them. This is how you have done it. Surface area for cube, again it has A square, it is same. Here length, breadth, height all are same. So this is square. Area is always given in a unit of square. Okay. So A square, because L is A, B is A, this is A square plus A square plus A square, that is 3A square, 3 into 2, 6A. Now curved surface area of a cylinder. What is the curved surface area of a cylinder? The perimeter of a circle is, or circumference of a circle is 2 pi r. And then you multiply by height, you get the curved surface area of a cylinder. Total surface area of a cylinder, you have this 2 pi rh, then you have to add 2 surface at the bottom and the top lid and the bottom lid. That is 2. What is the area of that? Pi r square. So you have 2 pi r square. So here is 2 pi r square, so 2 pi r is common. So r plus h. This is the surface area of a cylinder. Surface area of a curved cone is, we have shown it is pi r l. Total surface area of a circular cone is, again circular cone, you have the surface area of a cone plus the lid, pi r square. Surface area of a sphere is 4 pi r square, which we have derived. Curved surface area of a hemisphere. So this is the surface area of a full sphere. So half of this is 2 pi r square, the hemisphere. Hemi means half sphere. Total surface area of hemisphere, now you have this is for the hemisphere surface area, and then the lid. Okay. So the 2 pi r square, 1 plus 1 more pi r square, so 3 pi r square. Volume of a cuboid is length into breadth into height. Volume of a cube is length, breadth, height all are same, so it's a cube. A into A cube. Volume of a cylinder is, pi r square is the volume, is the area of the circle. Pi r square, I have said you put stacks h times blocks, pi r square circular box you put it h times, that is h. So it is pi r square into h. Volume of a cone is 1 by 3 pi r square into h. We have shown that any cone, pyramid and anything, it is 1/3 base into height. So this is volume of a cone means the circular area base is pi r square into height. Volume of a sphere of radius r is 4 by 3 pi r cube. This also we have proved. Volume of a hemisphere is half of this, is 2 by 3 pi r cube. Okay. So with this we have covered from chapter 5 to chapter 13 so far. And next we proceed with some other chapter that is chapter 1 to 4, which we have missed, and then later on we will go to chapter 14 and 15. So thank you. See you in the next lecture.